In the last video, we discussed the difference between pulse TIG and pulse MIG, and we focused on steel, and we talked about what the difference is, what the similarities are. Today's video is all about aluminum MIG and aluminum pulse MIG, and why you may or may not need pulse MIG on your aluminum. Aluminum is always supposed to be a spray arc application. There really is no short circuit in aluminum MIG. Aluminum MIG is always push the weld, it's always going vertical up, never down, and is always a spray arc. It can be a pulse spray arc. Same concept applies here. What happens is droplet detaches from the wire, gets thrown into the pulsed spray. So now, why are people ranting and raving about running pulse MIG on aluminum? Here is why. Aluminum has an oxide layer. This oxide layer melts at 3,800 degrees Fahrenheit. The aluminum itself melts at about 1,200 degrees Fahrenheit. Now, you have to look at it like this. I'm going to draw a magnified piece of aluminum here, pretending this is our piece of aluminum, and even though this is about 1.5 inches here, let's pretend that this is about 1/8 of an inch thick. So on top of this aluminum, you have your oxide layer. Depending on the oxide and what it is, dry oxide or wet oxide, this oxide layer is about 4 to 5 micron. So what happens now is when you do spray arc, the droplet has to grow to a certain size till it can detach and go into the material. As that big droplet goes into the material, it needs a lot of energy to penetrate through that 3,800 degree Fahrenheit oxide layer. It's a really hard oxide layer too, and it needs a lot of energy to break this open. And even though your polarity helps you here, people say, do I need alternating current on my MIG machine to weld aluminum? The answer is no. When you look at TIG, your EP is typically your cleaning. And then your EN is typically your penetration. And you set this on the balance, and if you set this on a balance on a Miller or HDP machine, typically you have it at 75% your balance, which refers to a 75% electrode negative. On some import machines, it's referred to as a 25% balance because they look at the electrode positive side than the negative side. Again, the math works out. It's 100% no matter which way you look at this. But 75% penetration, 25% cleaning. Now picture this. Even though the technical direction of electricity, per definition, it flows from the positive to the negative on a battery, in reality, the electrons, there's all these little electrons, and they really flow from the negative to the positive. So when you look at this, on MIG aluminum, pulse or not, with your spool gun, your gun is typically positive, and your workpiece is negative, DCEP. So really, your current comes from the aluminum out into the MIG gun, forming your droplets and your spray stream. So what's happening here, as all these electrons come out, picture this like a little guy standing there. with like a pressure washer in his hand and blasting the oxides off from the inside. Essentially on MIG aluminum, you are running 100% cleaning, electrode positive 100% of the time. Now the problem is that still heats up the material, and as the droplet comes down into the material, it still needs to break through that oxide layer for then the electrode positive, like the electrons from the inside blasting this off, to blow the oxide layer away. And as this big droplet comes down, it saturates this 1/8" material. This is like your molten puddle here, your weld nugget. It saturates that 1/8" piece basically all the way just to get rid of your oxides. Now, when you picture this a little bit more dramatic, where now you have material that is 1/16 of an inch, okay? And here's your oxide layer. Here comes your electrode positive MIG. The stream comes down. It forms the nugget. Next thing you know is you have a hole in your material. So this is where your pulse shines. Remember, the droplet is very hot but very small. So what happens is the droplet that is formed is a lot smaller. It's still very hot, but it's a tiny droplet, and it goes into this pulsed, into this interrupted stream of tiny little droplets. And as it hits the surface, it loses most of its heat and energy to break open that oxide layer, and then your penetration into the base material is a lot less. So you gain control. You can weld along the edge of a material where previously you were just melting it off. You can bridge gaps. You can weld on thinner material. For aluminum, where you don't have the option of short circuit, it is about the perfect solution. Now, there's always a guy out there that says, yeah, but with my spool gun and I can weld short circuit on aluminum. Well, that's all fine and dandy. If you weld short circuit on aluminum, the problem is the wire short circuits, burns back a little bit, then your welding arc establishes here. There, a little lightning bolt. And it's just bubble gum attaching to the oxide layer. Maybe like you have a piece that connects here and a piece that connects there, but you don't really have any good noticeable penetration going inside and creating a good bond. For sure, this will not be leak tight. And even in a structural application, it's prone to crack. It will crack. There is not enough fusion there on a short circuit weld to be worthwhile. MIG aluminum is always a spray arc application. If you have any more questions, leave them in the comments of the video.